Hey everybody. We've learnt about how to make tables of our data, particularly using Excel, and now we're going to start looking at how to make graphs using our tables of data. Here's a summary of the 3 most commonly used graphs that you'll use to show your results in science. The first one are simple column graphs or bar charts, depending if they're going horizontally or vertically. Horizontal are column graphs. Sorry, vertical, like this one, are column graphs. So column graphs and bar charts are useful for if you've got some categorical data in different categories compared to some numerical data which you've measured or counted. An example might be if you've done an experiment with the elephant's toothpaste reaction and you've used differently shaped flasks like a beaker and a conical flask. So the shapes of flask are your categories and they become your columns. And then the height that the foam reached, that's your numerical data. That will be your y-axis. Here's another example. Some students have surveyed the number of insects they could catch in different locations around the school. So the locations are along the x-axis and they're our categories. And then the number of insects caught is our numerical data on the y-axis. Okay, line graphs are the next type. Really useful because they can show a progression or a change over time. So they're always used to compare time against some other numerical data that you've taken. An example might be if you measure the temperature of your house each day for 1 month. And the key feature of line graphs is time is always on the x-axis. Here's another experiment some students did. They poured out a fresh cup of tea and they measured the temperature over a minute, 60 seconds. And so time is always on the x-axis. In seconds is the unit for this one. And then temperature was the dependent variable that they were measuring. And so that's the numerical data which goes on the y-axis. And you can see a line graph makes it really easy to show the trend and the pattern. And it can also tell the story of what happened over time with whatever you're investigating. Scatter plots are the final type. These are used to compare 2 sets of numerical data to see if there's a relationship between those 2 sets of data. So it might be something like you investigate the number of hours that students spend reading novels at nighttime or in their spare time, and then you compare that to that same student's assessment scores for their schoolwork. So number of hours is numerical data, and then their assessment scores is also numerical data. And scatter plots look like this, where we're not joined up like a line graph because each point is a separate coordinate that represents a separate person or a separate event in the experiment or a separate trial in the experiment. Here's another scatter plot. So some people have surveyed how many visitors visit the beach and then compared that to the temperature on the day. And so the daily temperature was their independent variable that they were investigating. And then they were measuring how many visitors attend the beach, and that's their dependent variable. So each dot corresponds to one particular day where they surveyed the temperature and the number of visitors on that day. The main challenge when you're presenting your data in science is to decide what's the best type of graph to show our results. And you want to base it on which type of data that you've collected, but also how you want your data to be shown. Do you want to show it as telling a story or a progression over time in a line graph? Or do you want to show your points as individual points because they're not related to each other?